All right, so today we are going to go over Le Chatelier's principle. And I like to think of Le Chatelier's principle like kind of like a teeter-totter. Okay, so we're going to have our line, and then in the middle we have our fulcrum, and that is going to be our balance point. Okay, so in these chemical reactions, if you have too much of something on one side, it's going to tilt to go the other way. Okay, so it's all about that balancing act. So I'm going to go through this first sample problem, and then after that, I want you guys to do the three below, and then share this doc with me just so I can look at it to make sure you're on the right track, comment back. This one is not going to be graded, but your next one is, because I want to make sure that you get some practice and all of that stuff before I actually go and grade one, okay? So some other things that we have to note as well is we also have this value here called delta H. Delta H is something in chemistry and physics called enthalpy, which basically is just heat. So here we have a negative value for delta P, or delta H, I'm sorry, oh my goodness gracious, delta H. So for our negative value, that means heat is getting made in this reaction, okay? So it's going to go on the product side. If heat needs to go into the reaction for it to happen, then that's going to be a positive number. Okay, so if it's a negative number, it goes in the products. If it's a positive number, it goes into the reactants. So if we look at our first problem that we have here is letter A, and this says if we decrease the concentration of H2, what's going to happen? So we have to look back at our chemical reaction and see that H2 is right here. So if the concentration of this goes down, we need the reaction to happen in this direction, so to the right, so that we can make more H2, so it goes up. So we would write that in our little equation as saying to the right. Or you can also say, if I could spell, towards the products. And it's going to go that direction to make more hydrogen gas. Okay, so that's going to be our first one. So if we decrease the concentration of hydrogen gas, the formula is going to proceed towards the right to make more hydrogen gas to replace what was lost. So if we look at the next one, it says B, increase of pressure on the system. So when we're talking about things being under pressure, that's only going to be gases. So we need to look at where there's going to be more gas versus less gas. So what we're going to do is find out how many moles of each gas. So 1 mole, I want you to think of that as molecules. Okay, so it's going to be molecules. So CH4, that is 1 molecule. 2 H2S is 2 molecules. Yes, Duke, I know, it's very exciting. CS2 is 1 molecule, and 4 H2s is 4 molecules. So if we just kind of add all this up, on the reactant side, we have 3 total molecules, and on the product side, we have 5 total molecules. So if we increase pressure, what's going to happen is we want to go to the side, or it's going to force us to go to the side where we have less molecules of thing because we are increasing pressure, so there's less space. So we need to make more condensed molecules. So if we increase pressure, it's going to go to where the less molecules of gas specifically are. So in this example, switch over to my other thing. It is going to go to the left to the reactant because there are less molecules there. Okay, so it's kind of like we are like shoving things in a clown car, as it were. If we increase the pressure, we're going to go to the side where there is less things already. For our next one, decreasing the concentration of CH4. So if we decrease the concentration of CH4, our reaction is going to go toward the reactant side in order to make more of that. Okay, so you kind of see the pattern that we're starting to make now. So it is going to go to the left in order to make more CH4. Oh, Duke wanted to come say hi. Say hi to. Can you say hi? He wants to go for a walk. Goodness gracious. Do any of you guys have pets that keep bothering you now that you're home all the time? All right, so almost done. So we're on to D. Some oxygen is added to react with the H2 to form water, okay? So if we're gonna add oxygen into the system, it says it's going to react with the H2 in order to make water, which we all know is H2O. So if some of that H2 gets made into water, are we going to have H2? Well, yes, we're still going to have some, but that level of H2 is overall going to go down. So this is going to go towards the product side in order to make more hydrogen gas. So our answer for this one is going to be to the right, or the product side, in order to replace H2 that was lost to make water. All right, we're almost done. So for our very last one, E, heat is added. So in this equation already, we know heat is a negative, so we know that we get that out of our system. So heat is made. So if we add heat to the system, this reaction is going to go towards the reactant side to help bring that heat back down to normal, okay? So it's gonna go towards the reactants because we have extra heat being added. It's gonna basically stop the reaction from happening, go back to the reactants to try to bring that temperature down. So answer for that last one, heat is added. It's gonna go to the left for the reactants side in order to bring the heat back down. All right, so I really, really hope that this video helped you guys out a little bit. And when you are done with it, please make sure that you are sharing it with me so I can go through and comment on it and double check to make sure that you are on the right path going through these problems. There are really not that many problems. There are only 3 of them that are all very, very similar to the one I just did. I'll leave the answers on here on the document so you can see the example, but otherwise, you guys have yourselves a super sparkly day.